Start working with the topic you have seen before, and that is slope and graphs of linear equations. And on the surface, this looks like a very elementary topic that maybe we shouldn't need to cover in pre-calculus, but because this is called pre-calculus, one of the main foundations of calculus is this idea of slope. And if you were to ask any of my calculus students right now if slope is important in calculus, they would tell you it's very important, and they've already learned why it's so important. So I want to just start by reviewing we're going to review one of the forms today and another one tomorrow. First, the easy one, slope-intercept form of a linear equation. And you know probably what this is. It's y equals mx plus b. That is a linear equation. Now notice, in a linear, the highest power of x is always 1. There will never be an x squared in a linear. And this, of course, is my y-intercept. And this, of course, is my slope. M stands for slope. Now, before we get to an example, we probably should review a little bit of what slope is. Now, everybody always thinks it's crazy that I sing this lame song to help you remember slope. But here's the thing. Everybody gets it mixed up whether y or x is on top. So if you sing this little song, by the way, did you know that in Greek, when we say delta, which looks like a triangle, okay, it means change in. So slope is defined as, and this is a very lame song, but you'll never forget it, delta y over delta x. And you have to sing it with that kind of country twang, and you have to be a little bit off key when you do it. But if you sing it that way, you will never, ever forget what slope is. Slope is delta y over delta x. Now, what do we mean by delta y over delta x? We mean delta means change in. That's actually the Greek symbol delta. Change in y over change in x. That's what we mean by slope. We're relating the changes in x and the changes in y. So if we look at this graphically, when I talk about a linear, okay, and we're talking about how steep is this line, we're saying how much change is there in the y's, that's like my delta y, compared to how much change there are in the x's. You've also heard this described as rise over run. That's another way you rise over run. There's a lot of ways we can say slope. Okay, slope can be delta y over delta x. It can be rise over run. All right, but the main thing is it's the changes in y that are on top, and that's why I sing the lame song and make you learn it. By the way, you'll all have to sing it on the next test. So let's get to some examples here. I'm just kidding. Strange thing is, though, I have had people come to me after taking the ACT, and they're like, your song saved me, because they got in the pressure of the test, and they're like, which one's on top? Is it X's or Y's? And they just sang the song, and it all came together. Delta y. So anyway, find the slope and y-intercept and graph. This will be pretty easy because you've done it before, but there are still some mistakes that people can make, and it is still very important that we get it and we get it right. So let's start with a very easy one, y equals 3x minus 5. If it's already solved for y, this is super, super easy, isn't it? The y-intercept, okay, we call this b. I'm just going to use b, is negative 5. That's the y-intercept. and the slope is 3. Now, but remember what I said. It's rise over run. So we can't just think of it as 3. It's 3 over 1. Okay, and the reason that's important is when we go to graph it, we have to use that, because now you're going to graph these, and you're going to graph them by hand tonight, not with the graphing calculator. We're going to come down where we start. We always start at the y-intercept. So I'm going to start at -5, and I'm going to put my dot for the y-intercept. Then I need to account for my slope. Well, my slope is 3 over 1. So I'm going to come up 1, 2, 3, and go over 1. There's my next point. Then I can go up 3, 1, 2, 3, and over 1 again. There's my next point. And there is the graph of my linear equation, which should always be a line, since it's a linear. All right? That one's easy. Let's talk about a couple other situations. What if they give it to you this way? 3x plus 4y equals 16. What do we have to do first? Somebody knows. Tell me. And if we're subtracting 3x, we need to solve it for y. That's what we're trying to do. So we're going to solve this thing for y first. And be careful with this, because some of you are still making some algebra mistakes when you're solving equations. 4y equals -3x plus 16. I want the x term first, because that's slope-intercept form. Then I'm going to divide everything by 4. And I wind up with y equals -3/4 x plus 4. Once you get that far, it's easy to graph. Let's go ahead and we have to sketch a graph of these by hand. So I'm going to start this time at +4, right here. That's my y-intercept. Okay, my y-intercept is 4. My slope this time, though, is negative, which means I'm going to slope down from left to right. So when I get ready to do my counting for my rise and my run, I'm going to count down 1, 2, 3, and over 1, 2, 3, 4. If you have a negative slope, it has to slope down from left to right. And I can get another point, down 1, 2, 3, and over 1, 2, 3, 4. There's my next point. And there is my linear equation. It's hard to get it straight whenever you're just putting hash marks on by hand. Okay? Now, one other thing. What if they gave you this? Just plain old y equals 5. Well, they're all straight lines. This is the slope is 0. Okay? If you see this, the slope is 0, which means it is horizontal. That's the word you were thinking of, not straight line. Horizontal line going through 5. Okay, if you see y equals 5, it's horizontal. What would you do if you saw this? X equals -2. Well, the slope is undefined, but we can still sketch a graph. It's perfectly vertical. Okay, we cannot describe how steep this thing is because it's perfectly vertical. It is a vertical line through -2. So if you just get x equals a number, it's easy to sketch that one, and we would say that the slope is undefined. All right? Now, the next thing is also some review, but believe it or not, even pre-calculus students mess this up. What if you're asked to find the slope and you're given 2 points? -5, -7, and negative 8, 3. Okay, this is very easy, but people mess it up because they don't pay attention to signs or they get their x's and y's switched up. So remember the song. Slope is delta y over delta x. So the y's go on top. All right? Now remember something. This is an x, this is a y. This is an x, this is a y. The most common mistake is getting the numbers switched around. So I'm going to start and I'm going to go negative 7 minus 3. Now if I start with negative 7 on top, then on bottom I have to start with negative 5. You have to go the same direction. Negative 5 minus negative 8. And I'm showing every step here because I don't want to make silly mistakes with my signs. I would encourage you to do the same thing. It's a short problem anyway. So I'm going to have negative 10 over negative 5 plus 8, which is negative 10 thirds, and that's my slope. Okay. Now, of course, there will be some with fractions, so let's do one with fractions. And you will have to do these by hand, not cheat and put it in the graphing calculator. 2/7, negative 5 thirds, and the other point is negative 12/7 and positive 1/3. So we're still going to follow the same plan. We're still going to use delta y over delta x. So if I start with the negative 5 thirds, it's negative 5 thirds minus 1/3 all over 2/7. Okay, now I'm doing the x's, minus negative 12/7. If you try to skip steps on these, I'm telling you, you'll make mistakes. It's a short problem anyway, so don't skip steps. So now on top, I've got like signs, and I already have a common denominator. So the top is going to become negative 6 thirds. The bottom is going to become 2/7 plus 12/7. So that will become 14/7 on the bottom. This one worked out easy anyway, because they're both whole numbers. So this will be negative 2 over 2, which is negative 1. Okay? Now, one last thing, then we're done. What if they give you a point, 3, 2, and a slope, 1, 3, 1/3, sorry. And they say find 3 additional points on this line. Find 3 additional points on this line. I think the only way to do this problem is with a graph. Okay, I think if you try to do this counting business in your head, you're probably going to mess it up. So what I would do is I would plot this point 3, 2. Right there is the point 3, 2. And I know if the slope is 1/3, okay, and I need some more marks here because I'm going to be going up and down and over and whatever. I know if the slope is 1/3 that I go up 1 over 3. So if I go up 1 and over 1, 2, 3, what point am I at now? Well, I know my y-coordinate is 1 more, so it's going to be 3, right? And I went over 4, 5, 6. So that point's going to be 6, 3. Okay? And then I could come down the other way. I could come down 1 and over 1, 2, 3 this way. So this point, that's easy. It has coordinates of 0, 1. All right? And then I could just keep going either direction, all right, to find the third point. If I kept coming this way, I would come down 1 over 1, 2, 3. And this point right here would be -3, 0. Okay? And we will stop there for today.